Well, hello guys. In this video, we're going to be talking about acid-base reactions and everything you need to know about these type of reactions, okay? But before we continue, subscribe for the channel so you can get all the notifications and videos I post on regular basis. Now, as a general rule, we're going to start by knowing, and this is a general rule, that when an acid reacts with a base, a salt and water is formed. Now, this is a general rule. Because sometimes you will also get carbon dioxide. Okay. Now, what is the important part is this salt. This salt, guys, that we are looking here, this salt has ions. It's made out of ions. In other words, it has a cation, a positive ion, and it have an anion, which is a negative ion. Okay, so all the salts, guys, are going to be in this way. They always going to be made out of cations, which are positive charged ion. For example, we have Na plus, we have Mg2 plus, we have, for instance, and this one is just an example, Fe3 plus. So we have, these are example of cation, guys. They are all positive ion, and ions, they are the negative one. And I really apologize about my accent. There are learners that complain they didn't understand clear about the anions word when I was teaching. So anions now become like Cl minus. For instance, these are some examples of an ion, but you did all this. O minus, F minus, and these are some just examples I'm giving you about an ions. Okay, so let's do it this way, like this. So that is important. Now, what else is very important here? Where are the anions and where are the cations coming from? And then we need to know that the anions will come from the acid. From the acid, guys. Okay, all the anions will come from the acid, and the cations will come from the base. Alright, so this is important. Now the acid is going to be the one that will give you the type of salt you are going to have there. Let's use here the same color. So here the anions are going to be, or the acids are going to be the one that is going to give you the type of salt. Alright, so now let's look at those different situations we are going to have, and this one is quite simple. I hope you are with me right now. Okay, so the different examples, or the main ones we are going to be doing is, for instance, hydrochloric acid will always form a chloride. Okay, so the hydrochloric acid will form a chloride, guys. We form a chloride salt. In other words, the salt will be having this ion. For instance, sodium chloride, potassium chloride, magnesium chloride. So those salts are coming from a reaction of hydrochloric acid with any other base, but you will for sure will get a chloride. Okay, the other example is sulfuric acid. Now, sulfuric acid will form always a sulfate. A sulfate which will have the ion sulfate. Let's see, SO4, SO4 2 minus. Okay, I think we must keep a line in between. That's much better. The third one we're going to be doing is the nitric acid. And if you get the trends now, this one will form a nitrate. And remember, the ion for nitrate is NO3 minus. These are the ions that are going to be involved in the salt. And the last one that it's important because we do it often is the ethanoic acid, guys. And the ethanoic acid will form an acetate with the ion CH3H3. Let's fix this one. CH3 COOH minus. This is the ion, guys. All you see here is the ions that are going to be formed in the salt according to a specific acid. Let's move it a little bit to the left. There we go. So that is what is important. This that we do here is going to give you the type of salt you will get. Okay, so this is so far the acid-base reaction, what you know now the salt that will form. Now we're going to be looking at different reactions, specific reactions. And the first one we're going to be looking is going to be the reaction between acid and metal hydroxide. Now what we need to know here, the first thing is that when an acid is going to react with a metal hydroxide, the reaction is going to give you salt. And remember, we just learned about the type of salt you're going to be involved here, plus water, H2O. So no gas is going to be released during this chemical reaction. Let's look at one example. For instance, let's look at hydrochloric acid, HCl, aqueous, plus let's, for instance, say sodium hydroxide, NaOH, all right, solid, and this one will give you a salt. Now remember, we said the type of acid will give you, or the acid involved will give you the type of salt. This one is a hydrochloric acid, and therefore the salt involved here is going to be a chloride. All right, but let's break this one into ions before we go on. So let's start with the acid. Acid have ion which is H plus, which is also aqueous because it is ions within the solution, and is going to be also Cl minus. All right, remember that is the ions of the acid, and this one is going to be dealing you a salt which is going to be a chloride. All right, now plus the sodium hydroxide is also made up of ions, which is Na plus, and OH minus. OH minus. All right, now when we go there, the salt is going to form when the negative ion of the acid is going to react to come together with the positive ion of the base. This one here, when they come together, is going to give you the salt. All right, so in other words, what we are going to have in the product, we are going to have the combination of Na plus, let's use the same colors there, combination of Na plus the Cl minus. These two guys will come together to form the salt. That two there will come together to form the salt. Okay, and then what is left is the positive ion of the acid and the negative ion of the salt, and that will give you the water, H2O. Okay, so what salt is going to be here? It's going to be a chloride. So if we go back to the reaction we have, in that is going to be sodium chloride and HCl, aqueous, plus H2O, liquid. Remember, the H2O is liquid. So this one is how this salt there is formed, which is called sodium chloride. This one is the reaction between an acid and a metal hydroxide. This is the way of doing it. Is always going to be like that. Any acid with a metal hydroxide. So now the second reaction we have to look is the reaction between an acid and a metal oxide. So let's look at that second reaction here. And as a general rule, when an acid, let's write it here, when an acid reacts with a metal oxide, then a salt is formed, and water. Very much the same as the reaction with a metal hydroxide. Okay, this is a general equation for the reaction of acid and metal oxide. All right, now let's look at one example. For example, when we have sulfuric acid and it's going to react with sodium oxide, for instance, sodium oxide. Now, if you get sulfuric acid, and we go back here, remember sulfuric acid will deal a sulfate. So this one is going to be sodium sulfate straight on without even writing the formula. The product here is going to be sodium sulfate plus water. Okay, that is what we are going to have there. Now, how this works? Sulfuric acid. Remember, the formula for sulfuric acid is H2SO4, right? And this one is going to be aqueous plus sodium oxide. You're supposed to know now how to write the formula, but this one is going to be Na2O. Now, sodium sulfate and water. Let's see where is this one coming from. So let's do the same as before. Let's break now the sulfuric acid into ions. So what we have here, we have H plus ions, aqueous, and we have the SO4, 2 minus aqueous. These are the ions that is coming from the sulfuric acid. However, note you have 2 hydrogens there, so it's 2 hydrogen ions that react with sulfate ions here. All right, and this one, all this one here is going to react with the sodium oxide that is also going to be broken into ions here. Now remember, the sodium oxide will be the combination of Na plus O2 minus. However, once more, note you have the 2 sodium, so you have 2 sodium ions and 1 oxygen ion there. All right, and now the salt is coming, as we said before, from the combination of a negative ion from the acid, which is the sulfate, and the positive ion from the base, which is in this case the sodium ion. So when these two combines, these two will give you the salt, guys. All right, and you can see the combination in the product is going to be the following. It's going to be 2 Na plus SO4 2 minus. This combination, as we just mentioned, this one here will give you the salt, which in other words is sodium sulfate, as you can see there. But this is not done there. You must get also in the reaction the water plus H2O, but I don't have a space for that one. So guys, when you come here to the net reaction, to the final chemical reaction here, so to finalize this one, you will get here the 2 NaSO4, the 2, but the 2 is not there, the 2 is at the back, is Na2SO4 plus water. This one is liquid state, this one is aqueous. This one is solid. Alright guys, so here is the reaction of an acid with a metal oxide. This one is how it breaks in ions and how it becomes the specific salt. This one here at the beginning of the video was very important because it tells you already before anything else what salt you are going to be getting there. Now, the next one we're going to be looking at is the reaction between an acid and a metal carbonate. So, for example, let's look at the reaction of nitric acid This is the reaction of nitric acid plus any metal carbonate, for example, calcium carbonate. I'm trying to look for ones that I didn't use. Calcium carbonate. Now, you know you are going to get salt and water. Now the salt, remember guys, is coming from, or the type of salt is coming from the acid you used. So if you use a nitric acid, you will get a nitrate. In this case, you will get calcium nitrate. Let's fix this word here. Calcium nitrate, and obvious plus the water. So this one is the reaction of a nitric acid with calcium carbonate. If we do this one, remember the nitric acid, guys, is a combination of H plus all this one is going to be aqueous plus the NO3 minus, also aqueous. This one is the nitric acid ions, and this one is going to react with the calcium carbonate. Now calcium carbonate is the combination of calcium ions, which is Ca2 plus, and the combination of carbonate, and carbonate is CO3 2 minus. These two coming together. Okay, now once more, the nitrate is coming from the acid, the negative ion, and the positive one from the base. So when they two combines, will give you the salt. All right, now in this type of reaction, which is a little bit more, let's say, tricky, you're not only going to get water, you're going to get water, and you're also going to get carbon dioxide. So here you get the water, but you also get the carbon CO2 dioxide here. All right, so when we combine this one, guys, what are we going to have in the reaction? We are going to have the nitric acid, which is HNO3 aqueous plus Ca CO3 2 minus. This will give you now the salt. When you have those, you see the combination there in green. The salt is going to be the calcium nitrate, and when you combine that one, is going to be CaNO3 bracket 2. Right, note the charge there, plus the water H2O plus CO2. Guys, this one is the reaction, or an example of a reaction with of acid with metal carbonate. We're supposed to be doing the reaction of acid with metal, but you got the idea now. Okay, so in the case of acid with metals, which is will be, for instance, 4 acid plus just a metal, for instance, in the reaction you will get the salt, which you know where the salt coming from. We already practiced 3 examples with this one, plus hydrogen. So in this case you won't get this one is gas, you don't get water. All right, guys, this one is the final one of the one we're going to be looking. They could be also, for instance, acid plus a metal hydrogen carbonate, but you got the idea. I'm not going to do all of them. Now, to finish this little lesson here, we're going to be talking about neutralization reaction, which in actual fact is everything we've done so far. Okay guys, so what is neutralization reaction? This is everything we've been doing up until now, guys. All these are examples of neutralization reactions, all of them. So what is this? It's the reaction when the correct amount of an acid solution and a base solution is mixed to form salt and water. So in other words, in a neutralization reaction, an acid will react with a base to form salt and water. Now, it doesn't mean that it's only salt and water. Salt and water will be formed, but it doesn't mean it's the only one. Sometimes there is also carbon dioxide involved, as you could see in the examples up. Now, important things here. During the neutralization reaction, these one are acid-base reaction. It doesn't need to be necessarily a neutralization reaction. It's a little bit more than that. Now, during a neutralization reaction here, all the acid and the base will be used up. So only salt and water will be at the end of this neutralization reaction. So at the end, you will only have this one. At end. And to know when the substances are neutralized each other, we are going to use indicators. And we're going to speak about indicator in another video. Please don't miss that video. It's going to be quite important and it's few marks in the exams. So how this one is going to work, if you have an acid and you add in a base to that base is going to start neutralizing the acid. When the acid is completely neutralized, so it's completely used up by the base, we say that that reaction is going to be neutralized. At that point, we only going to have salt and water. Guys, this is the end of the video. I hope you understand. I hope it's quite clear. It is very important. Next time we're going to be talking about hydrolysis, which is related to the salt that is formed here. Don't miss that video, you'll need it. But thank you for watching. Thumb up and subscribe for the channel. I'll see you next time. Mr. G here.